Hi folks, I'm in the equipment pad on a job that we're doing a site survey on for a commercial job. There's some different issues with this job, which are physical in nature, but we found another one that right from the beginning when we were here initially jumped out at us. This line right here comes from the heater equipment, and all those heaters are flow controlled. They will not turn on unless you have a certain amount of water flow through them. And then this big valve over here is the main return line. Once the water gets pulled through the system, this is a vacuum DE system. What they've done within this vac pack unit, which is what this is called generally speaking from a generic standpoint in our industry, they have return water coming toward me from that side, from that pump. And they also have return water coming from the heaters up from the bottom here and turning back. What they've done here though is they have the water deadheading. They have it coming in one side of a T, one side of the other T, and it's colliding in the middle. And I'm sure the theory that they had was just force the water this way, but it doesn't work that way. It's two trains colliding, so it slows down the velocity and the flow. And what happens is when it has to go through this side of the T and get back to the pool, if you pan over that way just a little bit, you'll see that flow meter. That meter, that tall meter, which is right here, is what gives us the legal requirement of flow or gallons per minute that has to flow through here. Well, we have two problems here. One is our legal requirements, because this water is colliding here and then has to be forced through here, it can make that meter drop. And even though in the big picture it may not be an issue, from a legal standpoint it can be. The other issue is if we're slowing down our water coming from our heaters going back to the pool because we have a bigger line pushing more water this way, we have bigger pushing against smaller, we may not get the flow that's required. So the way that it should be is this line should come in from here, and instead of coming in a T, should tie into this line over here with another T. Or even a 45, better yet, and allow strategic flow into there. And it's just simple hydraulics. Unfortunately in the pool industry, the industry as a whole tries to take a least point of resistance. Instead of spending an extra 5 minutes, an extra $5 so to speak, to get it absolutely correct, they take the least point of resistance and save that 5 minutes and that $5.